And this already leads me to the introduction of our keynote speaker, Professor Sotaro Kita. He is a professor at the University of Warwick, and he is well known for his research on the relationship between co-speech gestures, speaking, and thinking. As one of the leading researchers in gesture studies, his research is concerned with both speech gesture production and comprehension. Furthermore, his research includes the investigation of patients and neurophysiological methods. Together with his colleague Asli Öztürk, Kita put forward a very influential model on speech and gesture production. Today, Professor Kita is going to provide an overview of his research on the interaction between speech and gesture. He will introduce an exploratory corpus which was important for formulating precise research questions. Furthermore, he will talk about his more experimental studies, as well as a patient study, which also provided further insights into the link between gestures and speech. I'm very much looking forward to his talk, and please welcome all Professor Kita.
Thank you very much for coming early in the morning. Can you switch to the laptop? How do you? Yeah. Okay. Thank you very much for coming early in the morning, and also thank you very much for the organizer for inviting me to give a talk. And also, it's a very interesting idea to organize a conference, mainly for postgraduate students concerning methods. I think that's a brilliant idea. And I'd like to talk about my own research and how it has developed, and how different kinds of methods I ended up using in my own research. And what rationale, what are the reasons why different methods were used. And so it's going to be a little bit unusual talk, because it's going to be a bit of a history of my research, and that's not how I usually organize my research, but let's see how it goes. So the topic of my talk is spontaneous speech accompanying gestures. So these are gestures that people produce as they talk, and this is a quite ubiquitous phenomena. When people are speaking, there is gesturing. So even when you're talking on the phone, you probably have noticed that people gesture. It's ubiquitous across cultures. In every single culture, people produce spontaneously gestures when they speak, and it's also ubiquitous within the lifespan. So baby starts to use gesture before they start to speak, and as soon as they start to speak, they coordinate speech and gesture in a very systematic way. And even congenitally blind people gesture if they're given the right kind of task when they speak. So speaking and gesturing has really, really deep root together. And there are different kinds of gestures. But we're going to focus on what I call representational gestures, which refers to objects and events based on iconicity. So if I gesture like a throw, or ball bounced off the wall, these are examples of iconic gestures, and pointing gestures as well. So these are grouped together, and I refer to it as representational gestures. And the question is how speech production system and this gesture production system are interlinked with each other. And many of you probably have not really thought about gesture as a research topic, so I'll give you examples of what I'm talking about. So on the left you will see the stimulus, and this person in the middle watched that stimulus and then telling the story to this person And I'd like you to pay attention to the gesture she produces as she talks. So first the...
And then, let's see, okay, so the pan...
Sorry.
And then, let's see, okay, so they pan out of that, and then it goes to... And then, let's see, okay, so they pan out of that, and then it goes to, the bird is on the windowsill, up, on the windowsill again, and he's, by that same drain pipe he was climbing up before, and he pulls a box of wood, and then he gets like a long plank of wood, puts that on top of the box, and then he gets this, one of those like big weights, those, just a big weight that they always carry around in those stupid cartoons, and so he gets on one side and he throws the weight on the other side to spring him up to get the bird, and he grabs the bird and he goes back down and lands on the thing, and then he runs off. But as he's running with the bird in his hand, the thing that was up in the air, the weight, comes down and crashes on him, and the bird gets away. Okay, so then...
So this is a phenomenon I'm interested in. And so as you can see, there is a quite good coordination between speech and gesture. So the speaker is gesturing about what she's talking about.
And then, let's see.
And one of the sort of assumptions researchers in the field have is that these gestures reflect some kind of imagery that the speaker activates at the moment of speaking. So that speaker is imagining, trying to remember the cartoon and activate some kind of imagery of the cartoon, and that gets implemented as gestures. So these gestures seem to reflect some kind of imagery. So that's, I think, intuitively feels right. And I've been investigating exactly how the speech production process and this gesture production process are interlinked with each other. And I will tell you a bit of the history behind how the investigation went. And I think it's important to see, you will see that there's a methodological shift between two periods. The initial period where hypothesis is being explored, so where people don't know exactly what to test. I didn't know exactly what hypothesis to test. And then later, period in which hypothesis is very clear, and then you start to directly target these hypotheses to test. So starting from observational studies, semi-experiments where independent variables are not manipulated in the experimental sense, and then moving to more and more controlled experiments. And that's how the research expanded. And then more recently, I've been diversifying types of evidence, including studies on brain neurological patients. And in order to actually tell you the how my research methods have changed, I have to tell you a bit about the history behind the field, the history of the psycholinguistic studies on gesture. Up to 1990, people thought that the gestures are quintessential nonverbal behavior. And because it's nonverbal, psycholinguists thought that that's not relevant. This phenomenon is not relevant to psycholinguistics because it's nonverbal. Okay. And the real game changer was this book by David McNeil called Hand and Mind. As you can see, it's massively cited. I checked the Google Scholar citation yesterday, more than 4,000 citations. So this book was a real game changer because he said gestures are psycholinguistic phenomena. Psycholinguists got to look at, psycholinguists and linguists have to pay attention to gesture because there's this very tight and intricate coordination between speech and gesture. And this book is mainly based on qualitative analysis of spontaneous speech and gesture productions, and lots of theories, theoretical ideas. And then the rest of the 90s, not much really happened, except maybe I finished my PhD. And some sort of seminal papers started appearing in experimental social psychology journals, but not psycholinguistic journals. Then what I call the initial surge happened between 2000 and 2003. So David McNeil edited a book called Gesture and Language. And this book also became really influential, highly cited book. So he asked sort of key researchers in the field to write about their own study on gesture. So it was not just David McNeil's viewpoint on gesture, but multiple people's viewpoints were represented in this book. That was very important. And then this book also published 3 really highly cited theoretical papers about how gesture and speech might be related with each other. But at this point, because there aren't that many empirical studies, these theories are very sort of evidence thin. People really sort of speculate a lot. And then also in 2002 to 3, initial cluster of experimental studies appeared in mainstream psycholinguistics journals. So there's one paper in Psychological Science. I think 3 or 4 papers in Journal of Memory and Language appeared during this period. And that really, I think, triggered people's sort of, so that really gave important momentum. So people realized that, oh, we can send gesture papers to Journal of Memory and Language. Why not? And also, the journal Gesture started in 2001, so this is a journal dedicated to gesture studies. And also, International Society for Gesture Studies inaugurated in 2002 with its first conference. So these 3 years were really, really pivotal. And then, if you look at citations, sort of, worldwide web of knowledge, 2007 on, publications on gestures, especially in mainstream sort of experimental psychology and psycholinguistic journals, really picks up. And the literature expanded from just about speaking to thinking, the relation to thinking, and also lots and lots of neuroimaging papers started to come out. So, so that's the background. And I finished my PhD in the 90s, so I sort of witnessed this whole development of the field. And so let's get back to the my sort of actual substantive part of my talk. So the question I was interested in is how are the contents of gestures determined, and how the speech production system influence the content of what's encoded in gestures, and also sort of in terms of more sort of cognitive models, I was interested in exactly what process generates gestures. This is a long quote, but the initial sort of important evidence comes from cross-linguistic studies that I carried out. But in the 90s, this book by McNeil was extremely influential, but his initial observation was that iconic gestures are very similar across languages. A remarkable thing about iconic gestures is their high degree of cross-linguistic linguistic similarity. Given the same content, very similar gestures appear and accompany linguistic segments of an equivalent type in spite of major lexical and grammatical differences between the languages. And this resemblance, cross-linguistic resemblance, suggests that the gesture emerges at a level where utterance in different languages have a common starting point, thought, memory, and imagery. So that was the starting point. That was the received wisdom that we ended up challenging. And we really challenged the first part of the first slide, the first part of the quote about cross-linguistic difference. And this is the model that my colleague Sotaro Kita and I proposed in 2003. So this is a model of speech production based, speech and gesture production based on Leifeld's influential speech production model. So this scheme is the speech production. So you plan your communication, how it's going to be carried out. You generate a message, which is a proposition, to be encoded linguistically, and the so-called formulator select words and create a grammatical structure, select phonology, specify phonology, and that becomes speech. And then there's the equivalent, the action generator, which determines the content of gesture, and then that gets implemented as an arm movement. And this process is fed by various pieces of information from the environment, working memory, what's activated in the working memory, and what has been said in the discourse, and what the goal of the discourse is, etc. And there are a couple of important features in this model that distinguish it from other models. One is that there is a bidirectional link from speech formulation process back to the action generator, which determines the content of the gesture. So when gesture content is being decided, information from language formulation can have an influence. So that's one important feature. Another important feature is that the gesture content is actually determined outside of the speech production processing stream. Okay, so these are the two things that are quite different from other speech gesture production models. So those are the two features that I just talked about. And in terms of bidirectional links, we're going to focus on speech to gesture influence today due to the limitation of the time. So why did we propose that there should be speech to gesture influence? And the initial investigation was done with Sotaro Kita, and it's the basic idea, the basic phenomena that we wanted to describe was the fact that the information packaging in speech shapes information packaging in gesture. Okay. And we focused on what kind of information is packaged into a clause in speech, because clause is considered to be important speech production unit, planning unit for speech production. And the basic evidence comes from cross-linguistic variation in gestural representation, which seems to correspond to cross-linguistic differences in syntax. And we focused on what we call motion events. Something moves in a particular manner to a particular direction. So if something rolls down, manner of movement is roll, and the direction or path is downward. And the kind of stimuli we had was animated cartoon, very complex cartoon. You saw a different segment of that a few minutes ago. And this is a scene in which the cat is rolling down the street because he has a big bowling ball inside his belly. And if we used this kind of very, very complex stimuli, it was a long animated cartoon with lots of information, and people tell you a lot of different things about this. Because at this point in the game, we just didn't even know what the right questions are. So we but we wanted to see what kind of differences language might make. And so Zurek and I was just going through lots of sort of pilot recordings from from the three languages we understood, and we thought we have something that was unexpected based on McNeil's initial insight about iconic gesture being common across languages. And then we started to collect data more systematically using the same stimuli with a larger sample of participants. And so basically what we found was that when speakers talk about rolling down, they have, speakers of different languages have different sort of syntactic packaging of the information. So English can express the information using just one clause, roll and down, rolls down. But if you're speaking Japanese, you need more complex syntactic structure. You need two verbs. So basic, one for rolling and one for descending. So roughly speaking, this English translation will capture the complexity of the sentence. He or she descends the slope as he rolls. In Turkish, is almost word for word translation from Japanese. The structure is very, very similar. So if you're speaking Japanese or Turkish, you need two speech planning units. If you're speaking English, you can express the same pieces of information within a single planning unit. And this difference was reflected in gestures. So we classify gestures into three types. One is mana gesture, which is showing just the rolling part. Path gesture that's showing just the descending part. And mana and path conflated gestures, simultaneous gestures that shows mana and path in a single unit. And what we basically found that English speakers are likely to use this kind of gesture, in which mana and path are packaged into a single unit. But Japanese and Turkish speakers tend to separate mana and gesture into two separate gestures. So what you can encode in a planning unit for speech production is what you're going to express in your gestures. And I'm going to show you a few video clips that summarize the key results. I don't have time to show you the graphs, etc., but I'll just illustrate with examples. So the English speaker says, he rolls down the street into a bowling alley.
He rolls down a street into a bowling alley.
One more time. It's a single gesture expressing.
He rolls down a street into a bowling alley.
Mana and path. And it's a Japanese speaker who says, as he somehow rotates like a ball, he rolls, he descends. So same as event is expressed in quite different ways. Mana and path are separated in the gesture. Rolling, rolls and descends. And Turkish speaker says, as it keeps rolling, it goes. So gesture representations mirror the linguistic representations, and so one sort of interesting possibility is that the language people spoke really shaped these gestures. But from this data, of course, it's not the causal sort of directionality or the causal structure is not entirely clear. Did languages really cause the gestural difference? Or perhaps something else caused these differences. Perhaps culture-specific spatial thinking caused it. It's possible that these different cultures think about, represent spatial information in different ways, and maybe that was reflected in gesture. So it wasn't really the linguistic structure, but some other cultural differences. This Japanese-like structure increases. So that's what we used. So So we basically manipulated the event types and hoping that that would generate different types of expressions in English speakers. And indeed, with these sets of stimuli, we got both types of expressions from English speakers. And the key result is that when English speakers used sentence structure like sentence structure 2, they gestured like Turkish and Japanese speakers. So I hope this one works. So
he goes up the hill first, doing his spin.
So this is the mana incidental stimulus. So it's spinning up, but it doesn't look like spinning is causing triangle to go up. It looks like a triangle is just spinning for fun. And we obviously verified that with rating.
He goes up the hill first, doing
and then
spin.
Then that causes this kind of structure, sort of Turkish-Japanese-like structure and Turkish and Japanese-like gesture. So that's better. It looks like speakers' online choice of syntactic packaging of information influence gestures. But still, it is, the causal structure is still not completely clear. Because, so now it's clear that it's not about sort of cultural differences, because this is just about, this is within participant design, single person produces both type of structures. But the causal structure is not super clear yet, because what we manipulated was event type. That caused speech to be different, to be variable, and that caused gesture to be different, maybe. But it's also possible that these event types actually cause gestures to be different. So mana causal versus mana incidental might cause gesture to be different, and that might have caused speech to be different. So it's narrower in terms of possibilities, but still not completely conclusive. So, so this is the conclusion we wanted, but it's not completely conclusive yet. So, so in the next study, we went for a more direct manipulation of the speech, so that the causal structure becomes completely clear. So this is a work done with Lisette Demol. So Dutch speakers described motion events like this, the same stimuli we used, mana path, and speakers were actually explicitly asked to use 2 clause description versus 1 clause description of mana path. And Dutch works in a very similar way to English. So their sort of default way is to package information into a single clause, but it's grammatically possible to spread the information across 2 clauses. And then we looked at the type of gestures they produce. Mana path simultaneous or separate gestures. And so these are mean proportion of gesture descriptions. So each participant produced probably something like 10 gesture descriptions. And the proportion out of that, how many of them are expressing mana path in separate gestures versus a single conflated gesture. And if you, and this is a proportion, so these 2 bars are up to 100 or 1. So when they were instructed to produce in 2 clause description, predominantly the speech, as the gesture also separated mana path information, just like Turkish and Japanese speakers. But when they were instructed to produce 1 clause speech, proportion of conflated gesture went up very much. So, so this is, so this one provides us with more direct and more conclusive evidence that the syntactic structure used for event description is shaping gestural content. So, so with these 3 series of studies, from observational to more experimental, we established that the process that determines the gesture content gets information from how speech is formulated. So this arrow has to exist. So that's how this particular line of my research has developed. And in the sort of initial surge period, lots of different theories have been proposed between 2000 and 2003. Other sort of models do not really account for this phenomenon. All these different theories. So that's sort of one point that I'd like to, sort of empirical point I wanted to make. And I'd like to talk about another sort of feature of this model, which is that the gestures are generated from what we call the action generator. And this action generator is responsible not only for generating gestures, but also generating practical actions, like grasping a cup and grasping a bottle and things like this. And I mean, in some ways, probably a lot of you think that that seems like an obvious idea, but a lot of the gesture production model does not have this feature. A lot of gesture production models have gesture content being generated within the speech production system. Because speech and gestures are so closely coordinated, a lot of models actually propose that gesture content is determined in this stream. And our model differs from that. It's highly interactive with these bidirectional arrows, but it's a separate system. And one important piece of evidence comes from a neurological patient. And in this study, basically, we demonstrated the neuroanatomical dissociation between speech production and core speech gesture production. So basically, we showed that the neuroanatomically, this stream and this process are dissociable. And this is a study done with neurologist Hedda Lasberg. So if the action generator, which is outside of the speech production system, generates these speech accompanying gestures, then they should be generated by different brain structures from the speech production. And this, the key evidence came from our study on split brain patients. And so in these patients, the corpus callosum, which connects the cortices in the two hemispheres, the corpus callosum has been surgically severed to control epileptic seizures. And this gives us a really interesting opportunities to test which hemisphere generates a particular gesture. So for these patients, by looking at which hand they use to gesture, we can infer pretty precisely which hemisphere generated the gestures. And that's because hands are innervated by the contralateral hemispheres. And if there's very limited information exchange across the two hemispheres, then hand choice is certainly a very, very good source of information for the hemisphere that generates a gesture. So, and as you probably all know, in a majority of population, the right-handers, the left hemisphere is the language dominant hemisphere, and especially speech production seems to be highly lateralized. And so the question is, so speech production is here. The question is, can this hemisphere generate representational gestures? That's the question. So if that's the case, then we have demonstration of neuroanatomical dissociation between the two processes. So we looked at two split brain patients, NG and AA. These are the famous patients, the original split brain patients, which led to the Nobel Prize of Roger Sperry. So these patients are, at the time of testing, quite old already. But these are famous patients. They're right-handed. And it's important that they're famous patients because they've been tested thousands of times. And a lot of language tasks have been administered to these patients. And there is really no evidence for right hemisphere speech production in these patients. Lots of people tried. So one of the simple things they can do is to blindfold them and give them an object. What is this object? When they're holding the object with the left hand, they can name it. When they're holding the object with the right hand, they can say it's a ball. So that's the kind of classic sort of clinical psychology, neuropsychological test that people did. And there are various other kind of experiments to show, to investigate what each hemisphere can do in these patients. So they don't have speech production in the right hemisphere. And we show them a little sort of simple animated cartoon like this, where an object moves and bumps into each other, etc. And we asked patients to describe the cartoon to the experimenter. We didn't say anything about the gesture, but they spontaneously produced gestures. The question is which hand they use the gesture. So in this table, we show total number of gestures that we observed from these patients during this description task. The key thing is that so AA produced 44 gestures with the left hand, 36 with the right hand. NG was right dominant, but still produced left-handed gestures spontaneously. So at least some of the gestures are produced from outside of the speech production process. So the right hemisphere alone can generate representation gestures that accompany speaking, even in the patients with left hemisphere language production ability. So this demonstrates that and these left-hand gestures could not have arisen from the speech production process because right hemisphere just doesn't have it. So this is not compatible with the models that assume that the speech production process generates gestural content. There's a couple of papers that propose that kind of model. So let's sort of summarize what we have seen today. The first thing I talked about was speech to gesture influence. The speech production process gives feedback to the gesture production process, how the information is syntactically packaged within each planning unit of speech production. And this was discovered in an observational study initially, published, and then we did a semi-experiment across linguistic study. And then once our question became clear, then we produced stimuli just for that purpose and did a manipulation of speech first in an indirect way and then in a more direct way to really nail the causal structure behind the speech gesture production processes. And then the second sort of empirical point is that the gesture is generated by so-called the action generator, which is outside of the speech production system, and that came from the split brain patient study. So this is the model that we proposed, and over the years we accumulated different types of evidence to show. So we talked about this path today, speech to gesture path. I can give another talk if you invite me again to show this arrow as well. And then we saw the neuroanatomical dissociation data that supports the idea that the gesture content is decided outside of the speech production system. So the empirical take-home message is that syntactic structure shapes gesture structure. Representational gestures are generated from the action generator, which is outside of the speech production process. And going back to the theme of the conference, thinking about the methods that's been deployed in this series of studies. So in the initial surge period where experimental studies on gesture-speech relationship started, and lots of sort of speculative theoretical ideas being proposed in the literature. First, what we did was exploration of pilot recordings, because we want to show exactly what we are looking for at the beginning, followed up by semi-experiments, which is a cross-linguistic study, and then pinning down the causality, speech to gesture in more tightly controlled experiments. So this kind of sequence, I think, is very important when the kind of phenomena you're studying is relatively new in the field, and not much is being understood. And another thing I'd like to point out is that the split brain data is a serendipitous evidence, because we didn't actually start out this split brain project in order to test that particular hypothesis. When Hedda Lasberg approached me to work on split brain patients, I thought it is intrinsically interesting to see what hemisphere produces what type of gestures. And it took me like maybe 5 years after we started the project to realize that, oh, it's actually very, very informative about another program that I was thinking about, which is the cognitive model of speech gesture production. And so sometimes two lines of research converge in a very interesting manner, and so it's very important to be open-minded about different types of approaches and research questions, because they might actually converge at some point. So new area of research, exploration of ideas is important, and tight experimental control can come later. And also, another thing that I like to say is that the benefit of collaborative work may not be obvious at the beginning. Exactly what kind of you may have one goal, but then you realize that what you started to uncover is very informative about other questions that you've been thinking about all the time. So this is my sort of take-home message in terms of the conference theme of how you choose methods. And I'd like to acknowledge key collaborators of this talk: Astrid Zurek at Max Planck Institute, Lisette de Mol, Tilburg University in the Netherlands, Hedda Lasberg, Sport University of Germany. Okay. Thank you very much for your attention.
Thank you very much for this very insightful talk. And now we have time for your questions. Yes.
I wondered whether the data that you've collected has ever caused you to go back and change your initial
Hypothesis.
Yeah, and kind of change how you think about that initial model that you kind of came up with.
So that's a good question. I mean, we do that thought process all the time, especially when, especially sort of other researchers come up with sort of a new type of information that I wasn't really thinking about originally. How could this model account for that type of phenomena? So that does happen a lot. For my own research, I question myself all the time, but I haven't really come across anything that's really definitive that really forced me to change my mind about this just yet. But in the literature, there are some pieces of data that is problematic for that data as well. Yeah.
So I know the focus of your talk is on iconic gestures
Right.
and the shape of gestures, but another really important aspect of gestures and language is timing.
Timing, yeah.
And timing of gestures, I think, is very tightly controlled to the rhythms of speech.
That's right.
And I just wondered how that would fit into the picture that you're building in your model.
Yeah. So that model is not designed to account for timing. So I think you need a different kind of model altogether. And there are different type of things I mean, the timing of generating initial representation is one thing that needs to be investigated. Then there must be sort of lower level coordination as well.
Yeah, I was wondering if you
Like
have
sort of articulation and the motor
Yeah.
control kind of process might be. And there are some few initial studies. There are surprisingly not that many studies on this issue actually. There are only maybe 3 or 4 papers that are really informative. And so that's another really important issue. And I think you need a different kind of model. This is not supposed to, this is not meant to do that, inform us.
Okay, on the timing, at the Max Planck, they did some work decades ago now on timing of data. Pointing.
And then,
Richardson and Legel. Yeah.
That's right.
Which you would have to account within that one.
No, so this model is more about content.
But you said that the intic gestures were part of content.
Yes. Well, I mean, so I think it would account for sort of it won't account for the timing, but it would probably, I hope this will account for the content. So, what kind of people things say, and then what kind of things people point at. So that coordination, sort of content coordination, hopefully is accounted for this, but not timing.
Okay.
Yeah.
And then a follow-up. Presumably there are patients who have lexical access retrieval problems.
Yes.
Do they have action generation problems at the same time?
Not always. Not always. I mean, these areas are quite close to each other in the brain, so sometimes people have both deficits, just because the damage is.
Yeah.
But
No,
you could get the pure.
I was thinking about your arrows.
That's right. So there are several sort of interesting research on aphasia and patients and their gesturing. To be honest, I cannot really. The literature is a bit confusing, so I cannot really summarize in a nice way exactly what aphasia does to gesture. It's
Aphasics are not homogeneous. Yeah.
It's not homogeneous, and it's quite. But their gestures are not normal. Their gesture breaks down in a particular way. Yeah. But
in some of the literature on embodiment, there's this idea of a simulator which basically reenacts perceptual stimuli in a more fast way.
That's right.
So Barcelon's literature.
That's right.
At what stage in your model would you say that kicks in, if at all?
I think that must be happening here. So in terms of, so you might be processing information from the environment, but you could also imagine sort of working in a simulated environment. So this can also generate sort of actions that are actually simulations. Yeah.
Could you account for sign languages using the same model?
You mean gesturing within sign language?
No, just sign
language production.
Mm-hmm.
I never really thought about that. Yes, and how gesturing within sign language can be accounted for.
Well, you get a dissociation between gesture and signing for aphasic patients.
That's right.
So I suppose you could stick the gesture in the same place.
Right.
But it's where the signs are.
That's right.
You get mouthing in sign language as well.
That's a bilingual phenomenon.
That's debate.
Right. No, that's interesting. I never carefully thought about that. That's something. Yeah.
In your poster, you say something like syncretic structure shapes gesture.
Structure, yeah.
So, have you had something like English, Japanese bilinguals? If language shapes mind, so what's their structure would be like?
Yeah.
They're testing their L1 or L2.
That's an excellent question. So my collaborator, Uzurek, has done some studies on Turkish speakers learning English. And basically what she found was that the beginner or intermediate Turkish speakers use Turkish-like structures all the time in the English. So they don't say roll down, they always say, he was rolling and he went down. And then their gesture is also separated. But once for advanced speakers, we can actually say roll down. You see sort of English native speaker-like gesture. That's what Uzurek has found. And a PhD student from Birmingham, Mai, is working more on that kind of issue with Arabic speakers. And also, Isabella is working on that as well. So that's actually quite a hot topic. Second language, bilingualism and gesture interaction. So the two PhD students in Birmingham are working on that.
For your split brain patients, was there anything that marked out the non-linguistic gestures as opposed to the linguistic ones, so the ones that produced
by that?
So was there a pattern of which hand they used?
So that's an excellent question. So is there a kind of qualitative difference in the way gestures depict things? Is that for example?
Well, I guess the question is if they're producing some with the non-language dominant hemisphere, then
right.
What are they if they're not linguistic really, and how are they different to the ones that are linguistic?
I mean, they both sort of initial observation is that they look very similar to each other in terms of, I mean, they describe these movements. It went to the left and right and, bumped and stuff like this. But we did measure synchronization with speech, and left-hand gestures is less well synchronized with speech. I didn't present the data than right-hand gestures. So that difference we definitely noticed. But in terms of content, in terms of how they depict events, we haven't done really proper analysis